Okay, so maybe we can already start while the others join in. Hello, everybody, and welcome to our fifth session of the training series dedicated to turning biodiversity observations into insights. I am Christina, and I'm again delighted to be your host for the next hour and a half, when we'll be learning how to improve our visualizations from Professor Duccio Roccini. So I'm really happy that he accepted our invitation and took time from his schedule to be with us today. Please use the Q&A option to address your questions. We will try our best to answer them all. And yeah, hopefully you will be enjoying this Friday afternoon and learn amazing things. Just a couple of mentions for the people that are here with us for the first time. This training series is organized in the framework of the BCube project, which is funded by the European Union's Horizon Research and Innovation Program. It is a project that is aiming at standardizing access to biodiversity data, making it more rapidly and more reliably available to anybody that is interested. For people that want to learn more about the project, the aims, the outputs that were produced, please do follow up with exploring the bcubed.eu website. You'll find many interesting things over there, definitely. So just don't be shy, please have a look, and you'll see that I'm not advertising it for nothing. This is a project that is coordinated by Quentin Grum from Meise Botanic Garden in Belgium, but there are many amazing people that work in this project from different institutions across Europe and also beyond Europe. We even had some trainers for this training session series, from South Africa. In case you missed those sessions, there's still time to check them out. If you want, just go on the website, the project website, under the section news, and you'll find there all our previous talks, the recordings, the slides, many useful materials that you can just go through at your own pace. And today, as I was saying, we have with us Duccio Roccini, Professor Duccio Roccini, and he will be telling us more about making use of colorblind friendly maps. But just before I hand over to him, let me mention that there's still one more session you can join next Friday, when we'll be hearing about the B3 verse, suite of R packages that we can use to calculate various indicators. So make sure you join again next Friday. Okay, so Professor Duccio Roccini, he's here with us. I'm really happy. Again, it is my honor to introduce him to you. He's a professor at the prestigious University of Bologna, in Italy. And for his PhD, he dealt with remote sensing applied to estimates of biodiversity. He's part of a vast network of international researchers, among which is the US Geological Survey, or the University of Nottingham in UK, or the Ashoka Trust for Research in Ecology and the Environment from India. So he's really well recognized internationally, and he's passionate about promoting open source algorithms in ecology, helping developing the algorithms for computational, mathematical, spatial, theoretical ecology. So lots of interesting stuff, everything openly available. And again, I thank him for joining us today and for sharing a little bit of his experience with us. And before I hand over, um, if you've been with us before, you know already that I'm going to ask you. I will start the session with a tiny test, but very simple one, but which will help us a lot. So please do take the time. I kindly invite you to answer 3 quick questions about the country that you're based in and the level of your careers and the stage in your careers that you're at and in which sector you mainly activate. So hopefully you can see now on the screens, on your screens, the poll with the 3 questions. And I kindly ask you to just take a couple of minutes to answer them. It will help us, like I mentioned, to just get an idea about the audience and yeah, who's finding these training sessions really useful. And for the future, we can also prepare, maybe organize some more uh, training sessions if people are interested. Okay, so for the countries, I'm not sure yet how to see that. Maybe we can still wait a little bit of time for people to answer these 3 questions. So happy to see that we again have students joining us, but not only students, also people that are in their early stages, in the early stages of their careers, and people that are a bit more experienced. So we have, again, a good representation of participants. Maybe we can end the poll and share the results. In case you can't see them on your screens, we have people from academia and research institutes that have joined in. And yes, most of the participants are from academia and research institute. So about 50%, I think, I guess half. And the other half is represented by participants that activate in government or public administration, NGOs, or the private sector. Okay. And for the students, let's see. Again, half of our participants are either master students, PhD students, or postdoctoral researchers. And the other half is early career professionals or people more experienced. Perfect. Great. Thank you so much for taking the time to answer these quick questions. And now is over to Professor Roccini. Thank you for joining us.
Many thanks, Christina, also for this nice presentation. And I'm going to share my desktop in this manner. We can start. Okay, very rapidly. All right. So you're in. I'm going to open. First, I would like to explain how we will proceed. So there is a GitHub repo dedicated to this session. So in this manner, you can, I will show you what are the packages you need. You might have received this information, but let's check it together. So you can go directly to GitHub to my own account. How to do that? Simply open GitHub and search for me by user Duccio Roccini, and you will find me. And then there are all the repos, and here you can see the bcube color blindness, which is the repo we are going to use today. And here, but you have received this also by email. The main important point is this one. So we are going to make use later on of some packages. I'm going to divide our time in two different sessions. One is a presentation about the problem related to color blindness, while the second one is real hands-on. So we are going to code together something. And these are the packages that are needed basically. Some of them might be installed from GitHub or from the CRAN, and the others or directly from the CRAN. So for those from the CRAN, here is the function you will need. So install packages and then the name of the package, and that's it. For those related to GitHub, on the contrary, you should have the DevTools or the remotes package installed. And in that manner, you can use this function, which is install underscore GitHub, and the name of the package you will need, basically. Okay. So in this case, from the GitHub packages I used directly, I have put a comment with the name of the account and the name of the package. Okay, so this is the important point. So you can go to the page and you can install such packages, but the main point is that you might have studied them previously, since especially from those from GitHub, you might have something to check in your own computers. But this is not a big deal, since the main script that we are going to use, which is in the code folder, will remain forever. So you can just install your own packages after this time we are spending together and repeat the code. You can take just some notes now, and then you can repeat the code when you want, obviously. Beside all of this, I've also put the presentation, which is this one. It is called Quarto B Cube. It is a QMD, but I will provide you also with the HTML, the complete HTML of the presentation, since in this manner you can use such presentation as you want. So that's it. We are going, I also obviously made a README file here, so a markdown with everything written more or less about the aim today, etc., what we are going to do together. Okay, so the markdown, you can read the markdown after the seminar today. Okay, so first of all, I'm going with the presentation, and then we are going to code together. Right, so let me go to the presentation here. Okay, I'm seeing some questions. Christina, I would like to ask you if you can read I'm seeing a hand on. So let me see if there is something in the chat. There might be someone.
I don't see anything in the chat,
Uh,
but just please use the chat option or the Q&A option to address your questions, or if you
okay,
have any comments, because we can't open the mics for the
right.
participants, unfortunately. Thank you.
Okay, so just put your questions inside the chat or the other method that Christina stated. In this manner, we can read directly the questions. Since I can see a hand, but you cannot speak, basically. Okay, if there will be some questions in the chat, you can ask, and I will. Christina can might read, and I will reply immediately. Okay, so let's go with the presentation first. Okay, so in this manner, we can look at the problem. So the problem is this one. We in BCube, which is the project that you all know now, we are dealing with building data cubes for biodiversity. So basically, you can enter the site and you might know that here I can show you directly the BCube project, the nice site made by Pensoft, by Nicole here. And you have a library in which you have the possibility to enter the GitHub of the project, and here you have all of the packages that we are developing inside. Okay, so the idea is that we can build data cubes uh, concerning the distribution of species, the distribution of such species in time, the uncertainty related to such species. But then there is a part in which we should develop a framework for making the output. As an example, once we are dealing with maps, we should ensure that everybody can see the maps we are doing. I will show you how many errors we are making once making this output, especially for colorblind people. In most cases, in several cases, all of us have at least one paper in which we are using a rainbow color palette as an example. The rainbow color palette is ranging from the blue to the red, and it is completely invisible by colorblind people. So my aim today is to provide you with the possibility of developing maps that can be seen by everybody. Okay, so as I stated, in BCube, you are dealing with the development of such cubes, and which are something like this. Basically, you have geometries in a part of the cube, you have the species, and you have time. So in this manner, you can clump everything together and have a sort of data set and modeling for a certain species or for several species to model both the variability of a single species over space and time and the variability of biodiversity in terms of, as an example, of heterogeneity in space and time. Okay, so this is one of the aims of the project. And then once you gather the data about the sampling, you have seen during these seminars the nice seminar by Andrew about the GBIF as an example. So the possibility of gathering such data. And once you have gathered such data, you can go ahead with the mapping of the variability of such species. This is an example about the sampling of the planet, and we made an estimate about the data available. Obviously, in Europe, we have the highest amount of occurrences. So here, this map is just representing as an example, and this is colorblind friendly. This is representing the number of occurrences in the color, and then on a log scale, and then the distortion of the grids are based on a cartogram, which is distorting the grid based on the sampling effort. So the higher the distortion, the higher there is a bias in the sampling effort. So that's why you have a high amount of data for Europe, but also a high amount of dates in which people went to gather such data. So there is a high sampling effort. So the idea is that while you have, after you have sampled such data, you can go with maps. So as an example, you can have the possibility to map the distribution of every single species and then clump all of the species together and make a sort of community-based map. Okay, so I can show you this. Sorry, I was not expecting to move to my computer, but I will show you that with pleasure. So as an example, okay, this is the paper I was referring to, and this is the final map you can build. So as an example, you can have 4 different maps with 4 different species, and then you can clump these maps together to make a sort of final map representing the distribution of the community with the dominance related to every single species with colors. Okay, so colors are super important in our life as scientists, and we are not aware about their real importance also for colorblind people. So this is the final community map that you might build. What is the issue with color blindness? What is the problem, and how many people is affected by color blindness? Let's look at that in detail. So first of all, the perception of reality through colors. These might seem 3 different maps, but actually this is the same map. This is representing the biomass of the Alps in Italy, northern Italy. So you can see in the map to the left, you can see the biomass represented by the NDVI on a grayscale. In the middle, you can see a map representing the NDVI, still the same information with another kind of scale. On the right, with the scale which is saturated towards the green values. So you can obviously understand that while the first and the second maps can discriminate, and especially the middle map can discriminate among different areas, the final map, that to the right, is actually saturating everything towards the green. And so in that case, the information that we are carrying out is the abundance of high values of NDVI everywhere. But this is not the case. So the color is quite important to represent the final outputs we are making, both from remote sensing, but also from species data, etc. Okay, so sorry, I missed color blindness here in the middle. So introducing the issue of color blindness in both remote sensing data and spatial data, and I will propose algorithms to face color blindness in a straightforward manner. Sorry, there are a couple of missing writing just because I used quotes and they were come out from the slide. I will remake it before sharing. All of these will be done obviously in a free and open source software environment, so that we are going to share the old code for everybody to let everybody use the algorithms we are proposing. I will explain you first what is the problem with these colors. So first, what are colors? Colors in the electromagnetic spectrum are actually only waves, okay? So the higher the length of the wave, so the higher the wavelength, the higher will be the possibility of representing the colors with red. So the red color is related to wider wavelengths, while shorter wavelengths will be shown by blue colors, basically. Okay, so the color is actually a perception that every single brain have with respect to such wavelengths. In some cases, this is the visible spectrum. Actually, obviously, there are additional possible wavelengths, considering both wide wavelengths like the infrared and lower wavelengths like the UV, X-rays, etc. So the main problem is that while most of us are seeing this spectrum, some of us, 8% in total, is not properly seeing this spectrum. Let's see why. Imagine a certain source of energy here coming, and these are the colors that are expected from these wavelengths. And this is our eye, and the retina is having the perception uh, about these colors in a standard way, in this manner. Actually, what we call colors are just a sort of general rule that we are giving to all of us. As an example, if I speak about blue and red, all of us will know what I'm speaking about. While, as an example, if I'm speaking about light green and yellow, in some cases we can confound this part. This is that there is a bit of a confusion in this part of the spectrum. So every single eye has its own perception, actually. And this is sort of standard vision, but actually there are three main diseases which are hampering to see such colors. The first one is called prothanopia, the color that people with prothanopia cannot see is the red, and this will be the final vision that you might have with this disease. The second one is called deuteranopia, and in this case, the green cannot be seen. So this is the final color that people will see. And finally, there is tritanopia, in which you cannot see properly the blue from the original one. You will see something like light blue and reddish parts. Okay, so this is the main sketch of the problems related to the daltonism, namely to the color blindness. So as an example, I'm taking this famous alien from the Alien family, let's say, of movies, and this is called the xenomorph. So the xenomorph actually, in this case, once it is plotted with the rainbow color palette, cannot be scary for colorblind people, since colorblind people have no perception about the difference between red and green in most cases. Okay, so especially in the prothanopia and deuteranopia, which are the most frequent disease types. So in this case, this is not scary for daltonic people, while we are perceiving all of the different facets here of the xenomorph, from the red to the green, etc. Okay? And this is a simulation of what a colorblind person is going to see once we are using rainbow color palettes like this one. So in this case, to the left, you can see that there is a rainbow color palette with red representing one of the main patches over an area. And this is the perception of a colorblind person. And you can see how fuzzy this will be from their perspective. This is a simulation with prothanopia. Uh, every one of us, actually, as I stated, in our life, we made uh, this mistake. We used this color ramp palette. This is an example from a paper of mine from Methods in Ecology and Evolution. We were presenting a package which is called raster I can show you raster package, which is available in the CRAN. We are basically providing for most, if not all, of the diversity indices related to information theory. Okay, so during the presentation of this package in Methods in Ecology and Evolution, I decided to use one of my favorite areas, which is the Similaun Glacier, and it is in northern Italy, a very famous glacier. And this is the representation from a photo in the field, and this is its representation from the satellites. So in this case, as an example, I'm using the near infrared. So everything which is red here is vegetation, everything which is blue here, light blue, is bare soil, so rocks. And this is the NDVI, namely the biomass of the area. And in the bottom part of the graph, there is the mistake. So in this case, I used an entropy measure called the Renyi entropy, which is a generalized entropy measure, which is representing several different facets of diversity. So here I was using in these three maps the rainbow color palette, and in this case, all of these parts, which are reddish and green, and also yellow actually, are really confused for daltonic people. So this is a big mistake in our presentation of results. And the same holds for the Raus Q, which is a different metric relating both abundance and distance-based measures of diversity. And also in this case, I used the rainbow color palette, so additional mistake here, okay? In this case, we are lucky since the range of the index was toward lower values. So in this case, you will have blue and green, so it is more or less safe. But the legend is a big mistake, as well as the other maps are a huge mistake, since once colors are saturating towards maxima and middle values and maxima, colorblind people cannot see anything here, okay? So how to solve the problem? So we introduced the problem together, now let's solve it. There is this paper about the misuse of colors. This is coming out from Cramieri in Nature Communications, and it is going to show basically the fact that if you use rainbow color palette, you are increasing the discrimination among objects, but in these cases, colorblind people cannot see anything. So you can move towards other kind of continuous legends, continuous color ramp palette. And this is an example that we are going to use. This is really similar to a palette which is called Cividis from a package which is called Viridis in R. The Viridis package is this one. So you can install every time the library called Viridis, and this is the complete citation. We also made a paper together with Simon Gardner, Noam Ross, and Robert Rudis about the correct use of colors. I can show you rapidly, which is this one. So the mantra here would be make use of colorblind friendly graphs. So most of the images I've also shown in this presentation are coming out from this paper, and you will see this situation, okay? So in the Viridis package, they developed several color ramp palettes that can be used to solve this problem. And here are some of the palettes from Viridis. Actually, now they also made new names, so adding additional palettes like Viridis, Cividis, etc. This is the previous version, and this was also related to the Python version of the package. This is how they translate to colorblind people. And we developed a package which is called CBlind Plot, and it is available in GitHub. So you can basically download directly and install to R. with GitHub. We are going to use a C-blind plot later on during the hands-on. Okay, so this is the BibTech citation. As I stated, I will provide you with a complete presentation after the seminar. Okay, so we are going to use this package. The C-blind plot has been thought for colorblind people. The idea is that they can apply the Viridis palettes here, not by a trial and error procedure, but directly putting their own disease. So in the function, I've put the disease, they can put their own disease, and the rendering of the map will be the best for that disease. To do that, I worked with doctors in Milan. There is a famous hospital called the Sacco. They are dealing with the problems of the eye. And so with the Sacco Hospital, I have worked on this, some of the researchers there. I've worked on this problem, and I developed this part of the package related to such diseases. How it is working? So basically, we start with the import of the image and with Terra, basically. And then this is compacted in a single layer. In most cases, the basic function is using principal component analysis, so multivariate analysis, but we also have worked to solve some of the issues with multivariate analysis, working with neural networks. So in this manner, we can simulate the brain in the best manner, possible manner, and we can associate colors with the more or less real brain. But today we are going to use this method, which is the most simple. And at the end, we are going to make the plot with the colorblind friendly color ramp palette with the ggplot2 package. The main function that we are going to use today, it is called cblind plot here, cblind dot plot. So as you can see here, this is the complete function. And as you can see here, the function includes the image, so the image that you want to translate, and the CVD. CVD is related to the color vision disease. Okay, so in this case, we are going to use a certain disease directly. So the D in the acronym is meaning deficiency. I don't like this word since the fact that you're not properly seeing colors is not a real deficiency. It is another perception. So it is not a deficiency with respect to the standard vision. It is just a perception. But in medicine, this is called deficiency. So color vision deficiency is the correct acronym. And the disease is put here. So as a user, you will directly make use of your disease, prothanopia, deuteranopia, or trithanopia, as we have seen previously. And the map will be rendered thanks to the cblind plot function for that disease, directly for that disease. I started from this paper in Nature from several years ago. I will also put the correct citation here. So the basis is coming out from that paper is the real vision of these people. So here is the original photo. Here is the vision from prothanopia. Here is the vision from deuteranopia. Here is the vision from trithanopia. Okay? So I used this idea. These were psychologists basically looking and also doctors looking at the vision. I used this idea to apply the Viridis package palettes to these kind of ramps. Okay, so I took these ramps. I saw that as an example, the first ramp was similar to the CVD's palette. I used that in the Sublime plot package. The second one to the Viridis palette, and the third one to the Magma palette. So this was the idea. If you have a map with rainbow color palettes, you should not exit R going to a different site in the network to make trial and error possibilities to properly see this map. You will directly put in the function the disease. Okay, no trial and error anymore. So for the protanopia, we'll use the CVDs one, for the deuteranopia, the viridis, and for the tritanopia, the magma one. Okay, the main challenge is that once you're using the PCA, so once you're using multivariate analysis, actually you cannot control maxima and minima. So I will provide you for an example at the end of this seminar we are spending together to see that maxima and minima cannot be controlled in multivariate analysis. So you might make use of this function, which is called NC blind, and this is the complete function. Basically, instead of compacting the data, you are using a neural network to simulate the vision, basically. Okay, and these are the diseases that I was speaking about. This is also part of the Sublime plot package. So at the end, also our xenomorph can finally have its own role. So also people with color blindness can be scared by this animal, okay, this alien. So in this case, with protanopia, with deuteranopia, and with trithanopia. If you want additional insights, there is also this fresh book which came out. I can also show you the site from Springer. So this is the book, and here my idea was uh, to involve all of the, or most, but I would say all of the maintainers of ecological packages in R to make a book together. And this is implemented showing several packages, including the Sublime plot package. So you can look inside the book for several ecological packages, okay? And there is also a free code for that book. I can show you the page directly, which will be really simple. Okay, let me see. In the organizations, there is one with the book. So in this organization in GitHub, you will find all of the code inside the book. Okay, so this is quite simple. You can check for this organization. I can also put these in the chat before going for the coding. Okay. Okay, so this presentation has been done in Quarto, and the open source code is available in that QR code. Basically, it is leading you to my GitHub account. So also in this case, you will find the whole presentation. Okay, so now it is time to move to the coding part. So I'm going to the chat. I will put in the chat the the link to the book. Let's zoom to the chat in this manner. I can put everything. I will put the link. Oh, let me zoom out. Okay. In case there are some questions before the coding part, just let me know, or in the chat, or I will look at Christina if there is something in a question and answer section.
Not that I can see. We have
Okay.
provided links to some of the papers that were requested
Fantastic.
and to the GitHub
Perfect.
page.
Thank
Yes.
you very much. Thank you very much. Okay, so we can go now for the coding part. Okay. So you can go to the network and go to GitHub here. Okay, you can do two things. If you have your own account in GitHub, you can open your own account like this and search for me, like user colon Duccio Roccini. And then you can enter the repository, which is this one. I can also put this in the chat of Zoom. Just a moment, I'm going to do that. Okay, in this manner you will enter directly. Otherwise, in general, in the network, you can put github.com and then slash Duccio Roccini. You will arrive to my own account. Okay. Among the repos, there is this one about B-cube color blindness. Here is the presentation. And let me see, I am curious about the typo in the aim. Ah, okay. Since here I used the text BF, which is LaTeX. I copy pasted from LaTeX, and that's why in the final presentation you cannot see that, since this is actually a LaTeX command for the bold. Okay, sorry. Actually, the bold here was done, might be done only with the asterisk, which might be really simple. Okay. So if you are interested, before going to the coding in color blindness, if you are interested to Quarto, I can also show you very rapidly how to make your presentation in Quarto. So as an example here, you have seen the results of the result of the presentation. Here is how you can make a Quarto presentation. It is super simple. So let me go here in the source part. So basically, you are making the general header here, and you are putting images like this in your computer, and then you can import the images directly. But the nice point is that you can also make use directly of your own code, and this will lead to the output. As an example, if I'm putting the Viridis package, I'm just going to put the code, and then the citation will come out directly in the Quarto final presentation. You have all of this code from Quarto inside, do not save, inside the B-cube color blindness. So if you want to play by yourself, you should just open RStudio like this. If you want to play with Quarto, make a new file from the file part. You will make a new file. You will make a new Quarto presentation, and then you can start with my code. Okay, you can copy paste and you can play with basically. So here you can find the whole code that I used for this presentation. Okay, which is super simple at the end. Okay, then we are going with the code. So inside the B-cube color blindness repo, you will see different folders and different files. The first one is the code. Inside there is the script that we are going to use together. To speed up time, we will just copy paste the script, obviously. Then there is some data that you can download. Actually, this is an image from the Vininunca mountain, which is quite famous since the different minerals are composing one of the most beautiful mountains over the planet. Vininunca, which is this famous mountain in Peru. Okay? Okay? Then about the files, there is the README in which I provide for general information. And finally, there is the Quarto presentation. I cannot put directly here the HTML, so the resulting presentation, since it is too heavy for GitHub. So I will provide Christina with the presentation. I will just adjust something and provide Christina with the final presentation in these days. Okay. So now we can go with the scripting. The script is in R. I tried to put several comments inside, but um, in this manner you can understand what I am suggesting to do. So you can open R or RStudio. I prefer R in these cases since the graphical part in R is quite better. Okay, let me open R here. Okay, I will zoom out. Sorry, I should adjust the different windows to avoid overlap with Zoom. Okay, so let's look together at the packages that we are going to use. So you might have installed the packages previously, and these are the packages. If you did not do that, you can take some notes now, and then you can build the whole script afterwards. So the first one is called imagery. It is a package that I develop for lectures in remote sensing. It is basically providing you with the possibility of teaching in a very simple way remote sensing thanks to this package. And I've built this to provide students with very simple functions. I am building the vignette right now, and this is a package which is available both in GitHub and in the CRAN. So I am maintaining also that in the CRAN, but as you might know, the CRAN version of packages is updated every year, more or less. So fresh functions are actually in the GitHub version. But today we are going to use the basic functions. So the installation from the CRAN is fine. Okay. Then one package which is ultra famous is the Terra one. The library, the package Terra is managing all of the spatial data. Then we are going to make, I'm going to zoom for the zoom part, okay? We are going to make the colorblind check package, which is used for evaluating the different color ramp palettes. And colorblind R is used to simulate graphs instead of just maps. I would like that you also enjoy simulating graphs, basically. The patchwork is a super nice package, patchwork package in R. It is basically composing ggplots. So the idea is that you build your own ggplot here, you assign the ggplot to a certain object, and then once you have all of the plots inside objects, you can simply compose them with mathematical operators. So as an example, in this case, I have the P1, I have the P2 objects, two different graphs. One is a point graph, one is a box plot. And then you can add one plot after the other. So this is ultra simple. And if you want one plot on top of the other, you can use the ratio operator. So this is super powerful, okay? If you want, instead of making the par or the multi-frame, if you have ggplot stuff, you can clamp all together with the patchwork package. And finally, the Sublime plot, which is the package that I've shown you previously during the presentation to solve the colorblind people problems. Okay, okay, let's start. You can copy paste all of the packages. Obviously, you should have installed all of them. Otherwise, just take some notes or install thanks to the README file, but at the time being, it is better that you follow the coding. Okay, so first of all, we can, as an example, import some data from imagery. In imagery, which is the package that I've shown you previously, for teaching remote sensing is incorporating several functions, and they are all starting with im dot. So in this case, im dot list. Okay, you can copy and paste, and these are all of the images which are available inside the package. Okay, among such images, there is one called here, several of these bands are called Sentinel Dolomites. These are images from the northern part of Italy, so from the Dolomites. So let's use them. We can import all of them inside the stack thanks to the use of the im.import function, which is directly importing all of the files containing the sentinel.dolomites. So here you have 4 files, 1, 2, 3, and 4, and you can clump all together and import all together as a satellite image. So let's do it together. Copy and paste inside R, and here is the concept. So here are the different bands. The satellite image is composed by, in this case, by the band number 2, which is the blue, the band number 3, which is the green, the band number 4, which is the red, and the band number 8, which is the near infrared, from the Sentinel satellite. Okay, so I am referring basically to these bands. Here are the bands I am referring to: the number 2, which is the blue band, the number 3, which is the green band, the number 4, which is the red band, and the number 8 here, which is the near infrared band. Okay, so if I put sent as an example, I can see information about the data set, and you can see there are these 1, 2, 3, and 4 bands. Everything is referenced in the UTM zone 32 in the WGS 84. Okay, so now we can build an index, as an example, the NDVI. The NDVI is an index which is representing the biomass of an area. And the NDVI is basically based on the high reflectance in the near infrared and the low reflectance in the red from plants, since they are reflecting the infrared for by the mesophyll, so the palisade tissue, and they are absorbing the red for photosynthesis. And so here what you need in the function, which is called im.ndvi, which is still a function from the imagery, you will need just the name of the image, which is sent, and the layers containing the near infrared and the red. And the layers, as we stated previously, are the 4th for the near infrared, and the red is the 3rd. So let's use it and let's calculate the index. Now we have the NDVI, okay? And now we can build different color ramp palettes to show the NDVI. So we are going to reproduce the image that I've shown previously, okay? The image which is here. I'm going to show you just a moment. Let me go to the paper. Okay, we are going to reproduce this image here with the gray color ramp palette, the red and blue, and the green and red color ramp palette. Okay, as you have seen here, there is the gray color ramp palette, the blue, white, and red here in the middle, and the green here to the right. Okay, let's do it. First of all, we are going to copy paste the color ramp palettes here, and now we can make a par in which we are creating a multi-frame here with 1 row and 3 columns. Actually, if you install the imagery package from GitHub, there is a function called im.multiframe, which is doing the job. And here you can plot the NDVI with the previous color ramp palettes here. Col equals to the name of each color ramp palette. Okay, so let's do it together with the par. And in this case, I'm going to copy paste, and you will have the final graph, which is this one. Okay, and here this is a different area. So this is from the old Alps in the paper, while in this case, this is from the Tofane area, which is one of my preferred area. I can show you with a small video. I'm speaking about this monster here. I'm going to show you immediately. In this manner, you can also relax a bit. Let me go to the playlist, which is this one. It's this area. Okay, we can continue. Nice, right? You have perceived that in the middle of the area we have a huge amount of rocks. Okay, so the biomass, this is representing the biomass, in that case is quite low. Okay, now here you have the situation in which, as I stated, the first two maps are perfect in representing this. The final map is going towards a sort of saturation by the green, basically. And the map to the right cannot also be seen by colorblind people. These green and reddish parts cannot be seen at all. Okay, now we are going to look together how to solve that issue. Let's close the device with the devoff function. I prefer the devoff since I'm sure that it will work for everybody. So here I'm closing the device. And as an example, I've put other, let's say, potential manner to plot NDVI. So you can copy paste the first one here like this. So this can be seen by colorblind people, but just because you have green and blue. So it is still dangerous to use this color ramp palette to the right. Let's see the second one as an example. Also in this case, this is quite okay for colorblind people since there is the contrast between the blue and the green that they can see. You can see a lake here, which is this red part, but still the legend to the right is dangerous. And here there is something that colorblind people cannot appreciate at all. So this is the worst legend to be used once providing for outputs. Okay, so in this case colorblind people cannot see anything, more or less. Okay, this is the main point. Okay, let's simulate again colorblind people vision. I will just use this I will just simulate this graph here. I will show you. So let's do it together. First, we are going to open with the par a new device, and then we are going to create two different color ramp palettes. Okay, one from the red to the orange, etc., until the blue, and the other I'm going to show you. You can copy paste a sort of what a colorblind person is really perceiving. Okay, let's do it. You can copy all of this part, also the plots, obviously. Avoid, obviously, to copy the debuff. The color ramp palettes are called pale raw and pale gray. Okay, let's copy and paste to R, and this will be the final perception, okay, with the data that we have now. Okay, so imagine this is the image I used in the paper. This is the image coming out from imagery. So here you are using this color ramp palette, and this is how a colorblind person, more or less obviously, is perceiving it. This is I simulated it based on my contacts with the hospital in Sacco, Milan. Okay, so with this researcher in the Sacco Milan hospital, okay, who is called Rossella D'Introno. And so you can see what you are perceiving here to the left and what in the same image a colorblind person is perceiving. So this is ultra unfair in my opinion. So think at it once you're using color ramp palettes like the rainbow color palette for your output. Okay, let's use the devoff function here, and I will close the device. And now I would like to make an example with a data set, okay? So go to the bcube color blindness repo, and you can download this data, the Vininunca here. You can open, it is just a JPEG function, image, okay? So you can download to your computer. So as an example, in the desktop, in the downloads, wherever. As an example in the downloads here, I will overwrite. Okay, and now you can set your own working directory. As an example, the downloads. Let's set it. Here you should use the path to your directory, obviously. If you have problems to know the path, you can do that with the right button. If you are not successful now, don't worry, you can take some notes now. I will show you the image and then you can reproduce it. So here I'm going to import the image with the RAS function of Terra, and I'm going to flip it since the image is a JPEG without georeferencing, and so it is flipped. I can show you. So first of all, let's import with the RAS function. And then I have assigned it to an object called vin, so I can plot vin here. And you can see it is flipped. Why? Since once you're importing images without the georeferencing, R is not able to recognize north and south in some cases. So we can flip it here like this with the flip function, and then you can plot in the proper manner. Here, this is the Vininunca example from Peru. Okay, how a colorblind person is perceiving it, I can show you. Here there is a par in which we are going to make the standard vision and the protanopia vision. I use the RGB scheme here to do that. Obviously, do not consider the orange sky, since I have used this RGB to simulate just the mountains. So as an example, people without the possibility to discriminate red and green might see something like this, okay? Actually, it is not towards the blue, but rather towards the gray, more or less. Okay, so the main problem is that here you have the perception of what they are seeing. There is also a package which is dealing with the palette testing. The package is this one, colorblind check. I can show you. It has been done by a good friend of mine who is Jakub Novosad, a friend in terms of research exchange. I can show you. So this is the package, colorblind check. It is in the CRAN, and Jakub Novosad, who is developing the huge amount of nice things, developed it. He is also an author of the R coding for ecology book. So is also inside this book. Okay, Jakub made additional packages related to landscape mosaics, etc. Okay, let's use its own package to test the palettes, basically. Let me go here. Okay, so as an example here, we are going to use the rainbow function to simulate a rainbow color palette with 7 colors. And then let's make the check for colorblind people. Let's use it like this. So as an example, here you will have the palette with the common rainbow color and how the different people with different diseases, in this case, protanopia is the second, protanopia, deuteranopia, and tritanopia, are seeing such colors. Okay, so if you use uh, these nuances here, they cannot see anything. They will see brownish to yellow, more or less. Okay, brownish to gray to yellow. Okay, so the number of colors is here, 7. We can extend it as an example to 100 here, like this. And this is the perception with 100 of colors. So still, obviously, in this part, they cannot discern more or less anything. And we can extend till 500 or whatever. Okay, let's use it. And here you will have the 500 colors. It will be uh, slow. Unfortunately, sorry, I did not consider it since, yeah, this is too much. This is nice since this is even too much for us. So if with 500 colors, you cannot discern anything. You can have the perception that every one of us is equal, okay? With 500 colors in this small amount of space, you cannot discern anything. A chat GPT here would state, okay, this is the red, this is the gray, the green, this is the blue, etc. While we cannot do that with 500 colors. Okay. This manner, you have also the perception of how you feel once you cannot see colors. Okay, so there is another package that we are going to use. We are going towards the end of this and so on. So here, there is this package which is called colorblind R. This is nice since it is simulating the vision with graphs. So not with maps, but how colorblind people might see this graph, okay? You can feel how they are seeing that. Okay, let's do it together. Um, Here, uh, let's use the data set called iris here. If you want to have the perception of what the data set is, just use the head of iris. And here you have the different variables. Head means that you are taking the whole data frame and you are seeing only the first 6 rows. Okay. So here is an example. There is the sepal length, the sepal width, the petal length, the petal width, given different species. Okay. So the morphometric values given different species. About morphometry, I have also built some functions. I want to build a package in Python called the Natura Morph. You can play with this package if you want. The Natura Morph is this package. No, it is not a package actually. It will be a package. It is a sort of different scripts at the moment simulating different shapes of nature. So from the fern to corals to ink ring to this is the logogram of the famous movie called Arrival. Arrival movie, you should look at it since it is ultra nice. And the logograms are something like this. So we were speaking about shapes, and that's why I introduced the Natura Morph. If you want, you can play with this. Also in R, you can, in R Studio, open Python scripts and you can use them. Okay, so let's look at this. So first of all, let's make a ggplot with these two aesthetics, the sepal length given different species. Let's do it together. And here is the, sorry, I would close the previous one with the devof. Let's use the devof function and close the previous one. And then let's make again the ggplot. Since I assigned the ggplot to an object, we should recall the object. And here is the plot, okay? So you have different species here, different groups, let's say. And then you have the density considering different, in this case, as an example, the sepal length and the density, okay? So here you can see that this species, as an example, has higher density towards lower values. The green one has a medium situation, and the blue as the situation in which you have higher sepal length. Okay, this graph, how this graph is perceived, this is a density, kernel density graph, how it is perceived by colorblind people. You can make this called the CVD grid. CVD is color vision deficiency, so the color vision diseases that you are considering. You can do that. And here are the different diseases. So the deuteranopia, prothanopia, and trithanopia. So given the first map, graph, here is how they perceive it. And this is dramatic, right? Since they do not perceive the colors. And even worse, let's compare them. So I will make the graph for the perception of colorblind people, which is this one. Here is how actually you can solve the issue. This is a part for the perception, which was the previous. This is how you can solve it using these colors, which might be better for colorblind people. And now here you can see the difference. So here you have the situation in which you are using rainbow color palettes, and here the situation in which you are using other kind of color palettes. As an example, this is very similar to the viridis, more or less. The yellow is darker, but actually it is very similar. And this might solve the issue. Okay, the author here developed this palette, which is constraining the colors to be more similar for colorblind people. Okay, final simulation with the C-blind plot package. I recall you the C-blind plot package is in GitHub. This one, it is only in GitHub. And here is the logo. I've put the graphs with the Viridis color and palette. And here is an example with the original image in rainbow colors and also the new image with Viridis palette based on the prothanopia disease. So first of all, let's import an image which is called NDVI Rainbow. This is from imagery, from the imagery package that I'm going to show you again, which is this one. From this package, I recall you that all of the functions are starting with im dot. So we can put im dot list, and you will see again all of the different images. Actually, this can be accessed also from GitHub. Gesundheit to me, sorry. So I'm going to enter this from GitHub. In this manner, you can see that inside GitHub, imagery is containing the old set of data, which is this one. And here you have all of the images we are going to we can use in general. One of them is called NDVI Rainbow, and I'm going to use it. Actually, I don't know if, this one, okay. It is the representation of NDVI of a certain area with the color ramp palette. Okay, let's use it together. So im.import is our friend, which is going to import this image, which is in this list, NDVI rainbow. Um, and we are going to import this image called the rainbow. And you would see that it is based on a rainbow color ramp palette. Okay, so this is dramatic for colorblind people, obviously. So I'm going to flip, since this is just a PNG, so the correct one should be this, but this is not a big deal for us actually. Okay, now we can simulate, no, we can solve the issue. We simulated a lot of different images for colorblind people, how colorblind people are feeling those images. Now we can translate this image that cannot be seen by colorblind people to something that can be seen. Okay, so the first one is with the disease, which is called prothanopia. Let's use it here. I'm going to use that. So in this case, we are going to change the palette. In this case, we are going to call the palette, which is called the CBDs from Viridis package. So in cblind plot, you just put your own disease, which is prothanopia, and this is the new map starting from this, starting from the rainbow color palette. So here you have the original color palette, which is a mess, as I stated. Also in the paper, we are also stating, look, the green part is related to, I don't know, shrubland. The red part is related to woodlands. This is a nightmare for colorblind people. Okay, so with prothanopia, you will just put your own disease. With deuteranopia, you can put the disease inside, and you will have a new legend here, like this. And with trithanopia, you can put the disease inside, and you will have this legend. So all of these legends actually are calibrated on top of these diseases, based on the paper that I've shown you. Um, as I stated, there is another function inside the cblind plot package that I'm going to show you. Here, there is another function in the R, which is this one, the NN cblind. We are not using it right now, but in general, instead of performing the multivariate analysis, it is going to use neural networks to rescale colors based on prothanopia, deuteranopia, and trithanopia. I'm going to check this function in detail in this period. Okay, it would be nice to see something like neural networks to help colorblind people. This might be nice. I will think at it for the future. Okay. Okay, so let's just look again very rapidly to the uh, to the final part of the presentation about what we stated. We have done everything. So we simulated how the colors are telling us different stories. We stated that the perception by colorblind people is really different from standard vision. So there is a problem, and we can solve thanks to the Viridis palettes, starting from this sketch about how colorblind people are seeing colors, to this, which is applying directly a certain disease, which is coupling a certain disease with a certain color and palette to help colorblind people to see properly your maps. take home message, avoid this, and make use of the other kinds of palettes. Okay? Okay, so I can close the session. I'm going back to Zoom to see if there is any question you can ask. If you have questions in the future, you can send me an email and I will just proceed further with working with you together at something new, fresh about color blindness. Thank you for the moment for the to the whole audience for attending this seminar.
Thank you, Duccio. Really interesting talk. This is something definitely that we need to be mindful of going forward with our work, in case we haven't considered these aspects already. There is a question for you. Is there a way to create one map which caters for all the diseases instead of three, especially for scientific papers?
Yeah, this is a nice question. Actually, I focused on the three since these are covering more or less most of the colorblind problems. So that's why I used these three. Also in the literature, these are the three main issues, let's say. So that's why I focus on those. In general, we can also think at something calibrating. For additional diseases the different color ramp palettes. So that's why in the literature there are only these three, but actually obviously there might be some small calibration to be done for single people. So this might be also the case. Yes. I did not do that yet, no, nor I know someone who did that in the past. So it might be nice to proceed further in the future to consider a wider spectrum of different diseases. Also, not just color blindness, but other kind of diseases related to the proper vision of graphs, basically.
Okay, thank you for answering. Uh, I'm I'm not sure if there are also other uh, questions that people want to ask. And maybe
Otherwise, in case you can send me an
otherwise,
email, there is the email in the presentation. I will
yes.
also provide you, you have everything, so the code, the presentation in quarto, etc. I will also provide with the HTML. Obviously, I should correct just those small points using LaTeX, so I will move to the correct quarto markdown.
Perfect. Thank you so much
Okay.
for making available all of these materials uh, openly. But as you already mentioned, you are a keen promoter of open source algorithms. Yes. So thanks again for
Thank you very
sharing
much.
some of your
Thanks to all of
experience.
you. Christina, you
We
are
will,
going to. Okay, sorry.
yes, sorry, you wanted to mention
No, no,
something?
no. I would like to ask you, you are going to close the session, right? I should not do anything.
Yes, I
Okay.
will but just before we wrap up, I do have two more slides to share with
Nice.
our attendees. Yes, because on top of everything that Duccio has kindly provided to us, there's still extra materials that you can find on the project website, on the bcube.eu website under guides and tutorials. So everything is here openly available to any interested party. And again, give a shout out to our week, the last session of the training series. Already, time does fly by when you're having fun on Friday afternoons. Please do join us. Spread the word to your colleagues, friends about the session that we will be organizing next week. We have the B3 verse presented by three trainers, Sean, Ward, and Jasmine. It's going to be really interesting, same as our previous session, so please do join us next week as well.